Good morning, everyone. I'm Arpita Agarwal, Assistant Professor in CSC Department in Akgec. So today I'm covering TSTL BSCS code 303 and it is in second year of AKTU. So today I will be telling about graphs in degree and out degree. So what a in degree is number of vertices incoming. Number of edges incoming in the vertices contributes to in degree, and what out degree is number of edges going out from the vertices contributes to out degree. So we are taking an important theorem of it, that is so we have a theorem that degree of graph is the sum of degree of odd and degree of even vertices. So degree of graph is the sum of degree of odd and even vertices, and the sum will be even. Suppose we consider as this graph. We look if the degree of this, then it is 3, 1, 2, 3. If we look the degree of B2, it is 2, B3 is 3, and B4 is again 2. So if we add it, so 3 plus 3 is 6, 8 or 10. So it is an even number. So if we take an example to prove that degree of odd plus degree of even vertices is equal to the degree of even vertex of the graph. So if we look, if we consider a degree and sum it, then degree is coming even. So our theorem is proved. So I am taking another topic, types of graph, continued. Next is our null graph. Simple graph we have studied. We have studied multigraph. So these are null graph, a graph having no edge incident on it. Can you look any edge incident on it? On it? No. So this is a null graph. A graph having no edge incident on it is a null graph. So this is a complete graph. A graph is complete if it is connected. A graph is complete if it is connected. And number of edges in a complete graph is so this is a complete graph. So regular graph. So this is a regular graph. A graph in which all vertices are of equal degree. Like if we look for the degree means number of edges incidents on a graph, incident on a vertex. So if we look for the degree of V1, it is 2. If we look for degree of V2, it is again 2. Number of, then if we look for degree of V3, it is again 2. And if we look for degree of V4, then it is 2. So we can look all the edges are having equal degree. Such graph is a regular graph. Next है cycle graph. So this is a cycle graph. A graph forming a cycle is a cycle graph. So bipartite graph, it is an important one. If a graph is partitioned into two subsets and it is connected, it is a bipartite graph. Next is a graph is partitioned into two vertex spaces, two subsets, and every vertex is connected to second vertex set. Every vertex is connected to every other vertex. Like this. In which every vertex is connected to each vertex of other subset. Like this. This is a complete bipartite graph. Now, if we are given with a question, how many edges the graph K9 and K36 have. So we will apply the formula. N into n minus 1, remember we have studied just now in this lecture. So for K7, we will apply this formula, n into n minus 1 by 2, and we have 21 edges. And if for finding K3, 6 number of edges, we will multiply. This is complete bipartite graph. Then we have 18 edges. Now again we are given with another question. Again we will apply the formula n into n minus 1 by 2. Then again we will get 21 edges. And if we apply for K33, we will multiply it. Then we have 9 edges. Next is matrix representation. So we have to represent our graph with the help of matrix. So we have four vertices and 5 edges. We have to represent it with the help of matrix. So we denoted it as MR, matrix representation. So vertices vertex representation. Now we have any vertex between V1? No. V1, no, 0. V1, V2? Yes. E3 is edge we are having. V1, V3? Yes. E4 edge we are having. And V1, V4? Yes. E5 edge we are having. So again, we will put as 1 if we are having edge and 0 otherwise. Suppose we will look for V2 and V1. V2, V1, we are having any edge? Yes. Then we will put it as 1. V2, V2, no edge. We will mark it as 0. V3, V2, V3, yes. We have edge, that mark it as 1. And V2, V4, no edge. We mark it as 0. Now we will look for V3, V1. We are having an edge. We mark it as 1. V3, V2, we are having an edge. We mark it as 1. V3, V3, we are having no edge, 0. And V3, V4, we are having an edge. Then we mark it as 1. Now V4, V1. We are having an edge. We mark it as 1. V4, V2. No edge. Then mark it as 0. V4, V3, we are having an edge, then we mark it as 1. And V4, V4, no edge, we mark it as 0. This is about how we represent the matrix. We will mark it as 0 if no edge present, and we will mark it as 1 if one edge is present. Next, we will study directed and undirected graph. So a graph in which no direction is attached with edges so it is a undirected graph, and a graph in which direction is attached with edges is a directed graph. So if we look for the degree of vertex V1, then it is 2 because number of edges incidence on a vertex contributes to degree. If we look, degree of vertex V2 is again 2. Degree of vertex V3 is again 2. and degree of vertex V4 is again 2. So number of edges incident on a vertex contributes to degree of a vertex. Now if we look for incoming degree of vertex V1. So number of edges coming inside V1 is 1. So incoming is denoted by plus, and number of edges outgoing from V1 will be 1. Now if we look for V2, number of edges incoming from in V2 is 1. So incoming degree is 1, and number of edges outgoing in V2 is 1. So if we look for V3, number of edges incoming in V3 is 1, and number of edges outgoing from V3 is 1. So if we look for V4, number of edges incoming in V4 is 1, and number of edges outgoing from V4 is 1. So this is the incoming in degree and out degree of the vertices, and this is all about directed and indirected graph. So handshaking lemma is one of the important theorem, and it is asked most of the times in AKTU. So it says degree of vertices is twice the number of edges. I am repeating this theorem again because it is asked many a times in AKTU. So I am taking this with the help of example. So if we look the degree of vertex V1, it is 2. Vertex V2, it is 2. Vertex V3, again 2. And vertex V4 is again 2. So we can say that each edge is contributing degree to 2 vertex. Like E1 is contributing to degree to V1 and V2. Similarly, if we look for edge E2, E2 is contributing to degree 2 vertices, V1 and V2. Similarly, if we look for E3, it is contributing to degree 2 vertices, V4 and E3, V3. And again, if we look for E4, it is contributing to degree to 2 vertices, V2 and V3. So we can say if we have a vertex, then 2 edge will contribute to its degree, and this is our handshaking lemma. That is, statement of handshaking lemma is that degree of vertices is twice the number of edges incident on it. So with the help of this example, we can say that our theorem is proved. Thank you.